All right, this is chapter 15, lecture 1 still. We're on part 2. The lecture guide says, what is the iodide concentration in a saturated lead-2 iodide solution? And so the first step here is to write out the chemistry. So we're going to start with the solid on the left. So here's lead-2 iodide. And this is always going to be a solid. Write your equilibrium arrows. And then write out the balanced chemical equation for all of the ions that are produced. Now, we know that iodide, there's 2 of them, so we put a 2 in front of that. And iodide is a -1 ion because it's located in the group 7 of the periodic table, the halogens. So because the iodide, because we have 2 of them, contribute a total -2 charge, this must mean that the lead ion is a +2 charge. So this is a lead-2 ion. Use Appendix J in your OpenStax book to find out what the KSP value is for this. It's 8.4 times 10 to the -9. That is very small, so this is a very insoluble substance, slightly soluble. Now what you want to do at this point is, using all of this chemical information, set up an ice table. So on the side here we'll set up I, C, E. And the way we're going to pretend like we're doing this experiment is that we have 1 chunk or 1 mole or 1 crystal of lead iodide, and we have pure water. Pure water should not contain any lead ions or iodide ions. And as this substance reaches equilibrium, it's going to dissolve slightly. The concentration of lead-2 ions is going to increase, and the concentration of iodide is going to increase. And I want to emphasize here that it's going to go up by 2x because of the 2. All right. And that's the number one thing that students can leave off by mistake when doing these ice tables. So add your columns. We have 1 minus x, we have x, and we have 2x. Now here I'd like to point out that this is a solid, so we really don't care about any of these values. I just have people put a number 1 in there because it sometimes bothers them if they leave it blank. Now, so that's our ice table. Step 3, we want to write out the equilibrium expression. KSP is going to be equal to the concentration of lead 2 plus times the concentration of iodide, which we are representing as 2x there, right? Well, I'm sorry, I'm getting ahead of myself. It's going to be iodide, but it's going to be squared, okay? So we're again using that 2 in the chemical formula to put the powers on the concentrations, all right? Now when we substitute things in here, we're going to enter x for the lead ion concentration, and we're going to enter 2x for the iodide concentration. That's what I have here in the box, and that's going to be squared, okay? So we could run into some simple errors if we're not careful. This is x, and then this is basically 2 squared times x squared, okay? So 2 squared is 2 times 2, which is 4, and x times x squared is x cubed. Okay, and we're going to take the KSP value way up here, and we're going to insert it here. And we're going to divide both sides by 4. All right, so we have 2.1, whoops. 2.1 times 10 to the -9 is equal to x cubed, and then we want to take the cube root. the cube root. So on my calculator, I have a cube root button, so I'm going to go ahead and do that. And what I get is x is equal to 1.28 times 10 to the minus 3. Okay, so this is step 4, finding out what x is. Now, x is just a variable, right? So when we come back to this table here, we know that the concentration of iodide is represented by 2x, okay? So iodide is equal to 2x, and so I want to substitute it back into my ice table to find out what the iodide concentration is. And that's going to be 2.56 or so. I'll round this off now to a final answer. 2.6 times 10 to the minus 3. Okay? And this is the concentration of iodide in units of moles per liter or molarity. Okay? Let's do another practice problem. What is zinc ion concentration in saturated zinc phosphate? Okay. So zinc is a +2, not really transition metal, and phosphate is a -3 polyatomic ion. So keep that in mind. So let's go ahead and write this equilibrium out. Zinc phosphate Okay, there's 3 zinc ions. And there's 2 phosphate ions. Okay. The KSP for this is equal to 9.1 times 10 to the minus 33. Okay. So we again set up our ice table. We pretend like we have one chunk of the solid substance that dissolves ever so slightly to produce ions. Okay, so this goes down by x, and watch out for your coefficients. This is going to go up by 3x, and this is going to go up by 2x. All right. Now we have, well, I was going to circle that. Now we have the final concentrations of the equilibrium. And so we want to write out a KSP for this. This is going to be zinc ion. I'll pull this down a little bit so you can see those coefficients again. It's going to be zinc ion to the 3rd power times phosphate to the 2nd power. Okay? And we substitute these values in. I'll switch over to blue maybe. So this is going to be 9.1, 10 to the minus 33. And that's equal to 3x cubed times 2x squared. Okay? And I'll separate out the coefficients from the variable here. So 3 cubed, remember, is 3 times 3 times 3, right? So that's 27. And x cubed is written like that. And 2 squared is 4, right? And x squared. And so remember how to do x cubed times x squared. You add the superscripts, right? The powers. So 27 times 4 is 108. and that's x to the fifth, and that's all equal to 9.1 times 10 to the minus 33. We want to divide both sides of this equation by 108, and I get 8.4 times 10 to the minus 35, and that's equal to x to the fifth. And here's where you want to do the fifth root on your calculator. And when I do that, I get 1.5 times 10 to the minus 7. Now remember that the zinc ion, if you look back on the ice table, right, is 3x. So we want to multiply that by 3. Okay. And, you know, that's 4.5 times 10 to the minus 7. Okay. Whoops, why did I put that in brackets? Okay, so that's molarity or whatever units, okay? So we're done with that. This video is getting kind of long. Let me give you a practice problem. What is the Ag plus concentration in saturated Ag2CrO4? Okay. I'll go ahead and give you a KSP value for this. So you don't have to look that up. And I just want to give you a couple of hints. Silver is a +1 ion that's in the transition metals, and chromate is a -2 ion. This will help you balance the equilibrium, okay? So I want to know what is the Ag plus, okay? And that's going to be in units of moles per liter or molarity.